Okay, today is the first day of circle trig. And so, of course, we're going to be drawing some circles. I have in the room here some compasses, or is it compi? I'm doubting it. It's probably compasses. And you're going to be drawing a whole lot of radiuses, or is it radii? I think it's radii. Anyway, and then you're going to figure out what a radian is. Obviously, it has to do with a radius and circles. And I'm going to do this activity. I'm not going to record the activity right now because I don't think it'll work well because we're doing a lot of drawing and stuff in here. So I'm going to pause for a moment while we do this radius activity, radian activity that involves radiuses. And I'll come back to the video once we're done with that. Okay, so we're done with the activity, and the main thing I hope that you connected is that 180 degrees was pi radians. If you divide that out, then you'd have 180 divided by pi, which would give you about 57 degrees for a radian. But a radian has this and this and this are all the same. That distance, and that distance are all the same, and then you get a radian. Anytime, by the way, just to clarify, this doesn't just work with Skittles. If you made equal distances here and here and here, you'll get this angle to be a radian, which will be about 57 degrees-ish. Yes?
We don't have this slide.
It's okay, you don't need this slide. Okay, so now, here's the big formulas page that you're going to need. S equals theta r is a formula that you'll need, but even more important than that is the one for radians into degrees. So I need to add a page for that. So hold on just a second here. I'm having my board's out of alignment. So do you get that? I just said a second ago that 180 was equal to pi. Do you get that then that's what's called a conversion factor? And if I have like 60 degrees and I want to change it to radians, I can times by either 180 over pi or pi over 180. And do you guys get, I hope by now from science you know how to do this so you set it up so things cancel, right? So where do I want the 180? In the bottom, good. And if that's 180, then this must be pi, and therefore the degrees will cancel. And let's actually do that. Change 60 degrees into radians. Do it right now with your group. And don't give me a decimal. I don't want a decimal. I want the exact answer. Because as soon as you say pi is 3.14, you're rounding. I want the exact answer. That means you must leave pi in your answer. The answer is not 6 pi. You got something messed up. Okay, would you agree that 180 is the same as 60 times 3? You with me on that? And therefore the 60s can cancel and the degrees can cancel, and therefore it's just pi over 3. Raise your hand if you have that one right. Now, what is that? It's about 1, right? It's a smidgen over 1 because pi is actually 3.14. So 3.14 divided by 3 is a little bit more than 1. So what did we just figure out? 60 degrees would be a little more than 1 radian. Remember how radians were actually like 57 degrees? So it makes sense. Okay, let's try another one. Let's say that you had 90 degrees. How many radians is that? Multiply by, what's that thing you multiply by? Pi over 180. And that'll give you, cancel, pi over 2. Half of a pi. Do you get 90 degrees is halfway? A 90-degree angle is like this, and it's halfway to 180, right? So it's half of 180, and therefore it should be 90. 90 is pi over 2. You're going to eventually get good enough at this that you'll be, I'll say, like, what's 60? And you go, oh, that's pi over 3. You'll know these. Really, you will. It takes a little while, but after a while I'll say, okay, it's 30 degrees, and you go, oh, it's a pi over 6. You'll just know it. Okay, but between now and then, you have to multiply by 180 over pi or pi over 180. So one last one to see if you really got this. Let's take 45 degrees. Would you change that, please, to radians? I'll give you this hint. In 180, there are 4 45-degree angles in a 180, right? So that'll help. Okay, did you multiply by pi over 180? Did you then, gentlemen, did you then change the 180 into 4 sets of 45? That would have been smart. Cancel, cancel, pi over 4. Raise your hand if you had that one right. Okay, good. Now, what if we go the other way? What if I have 2 pi radians? You know how many degrees that is? Do you know how many degrees that is?
90.
It's 2 sets of pi. You can multiply by 180 over pi. And then the pi's will cancel, and it's 2 times 180, which makes 360. Okay, good. All right, so now, that's how you change back and forth between radians and degrees. And what you saw a second ago was this. I like to rearrange it and put the theta here. S equals theta r, that way I can say it's the SOAR formula. S-O-R. It's not actually an O, it's actually a theta. But this tells you the arc length, dumbest letter in the whole, like, this unit. Why on earth do you use an S for arc length? Anyway, it's the SARC, I guess. Anyway, the arc length on a circle is something like this. It's like, how long is this piece right here? It's curved. That makes it harder to tell how long it is, right? Because we can't use like right triangle formulas and stuff. But let's say that this was 8. Then I could easily tell how big that arc length is using this little formula. I don't know the arc, so I put S. Theta is the angle. This angle. We have to use radians for this formula to work. One of the reasons that I started with converting degrees to radians. So how many degrees would this thing be? 90. Can you change that to radians then? 90 would be how many radians? Well, you could always multiply by pi over 180 or 180 over pi. Which one is it? Pi over 180. Pi over 2. So my angle was pi over 2. I know that's going to feel weird for a while. It's saying, angle? What do you mean angle is pi over 2? Yep. The angle is 90 degrees, which can change to pi over 2 radians. And then the radius. I told you that. What is it? So therefore, it's 8 pi over 2. Can you simplify that down? 4 pi. If I needed a decimal, I'd just go 4 times 3.14. So it's about 12. Maybe a little more, because there's a decimal at the end, right? All right, so that distance would be around 12, a little bit more. All right, let's do another one. Let's say you had just this much smaller wedge. This right here, and this is a 30-degree angle. And let's say that the radius is 5. I want you to take a moment, do the calculations, because theta isn't just 30. If it was 30 times 5, it would be 150. It would be so easy, but it's not. You got to use radians. I'm going to pause for a moment while you give this one a try. You're trying to find this arc length right there. Okay. So tell me how you did it. What did you change your 30 to?
Pi over...
You multiplied by something, didn't you?
Pi over...
Excellent. And then you changed the final answer, pi over 6 is correct. Times it by 5. 5 pi over 6. It's about 15 divided by 6, a little more, right? Because it's 3.14. Make sense? Okay. The last thing is the area of a sector of a circle. You did this a long time ago, and it's really easy. If I knew the area of this circle was 100, and this was a 30-degree angle, do you get, I have pi r squared for the area of the circle, but I only have part of the area of the circle. It's not half the circle, it's what? 30 over 360. Exactly. See what just happened there? It's a fraction of the whole circle. And the fraction depends on the angle that you have. All right? So this one's 30, and the degrees will cancel, and I can cancel with 0. 336, can you reduce that? 1/12. And then pi r squared, and if I just know the radius now, it'd be super easy. Let's say I said the radius was 1. You will have to know the radius to find this, yes. And so if I put in a 1 here, then I have 1/2 pi, so about half of 3, so about 1.5. All right, I'd like you to get the area of this sector of this circle. It's not a 90, it's half of that. So it's a 45-degree angle. And this part right here is 10. Tell me the area of this sector of the circle. Would you agree it's not pi r squared, but it's a fraction of that? What is the fraction of it?
Well, 360, no. And then on top it's 45.
Yep. There you go. 45 over 360 times pi r squared. And what is the radius in this case? 10. So r squared would be 100. So if you can simplify down 45 over 360, well, there was 4 45s in 180 degrees, so there'd be 8, and there'd be 1/8 pi times 100. So that's really 100 pi over 8, and yeah, you can simplify it down from there. But that's basically your area of that sector of the circle. Now that's actually very accurate because we never rounded. We left pi in there. All right, so your homework for tonight is just like that. It looks like this. And the first part is just about degrees, minutes, seconds. There was just too much in today, so I'm skipping that. It's super easy. It's a button on your calculator. You go TMS button. No big deal, but we're skipping it. We'll come back to it later. It's on a future date. Get to this page. The yellow one is the first one we're actually doing. We're starting with this one. Okay. So it's asking you to convert this angle from radians into degrees. The 12-minute warning, it's perfectly timed. So pi, I know some of you may have already memorized it, but you could multiply it by, it's either 180 over pi or pi over 180. Which one is it? 180 over pi, and then the pi's cancel, and so apparently it's 180. Raise your hand if you already knew that. Cool. You've learned something powerful, because 180 going with pi is something that's critical to understand about radians. Okay, negative 2 pi over 3. What? Yes, radians and regular angles can be negative angles. You'll learn more about that later, but just for right now, trust that the answer does come out with a negative in it. And how do I change 2 pi over 3 into radians? I just multiply by the right thing. It's either 180 over pi or pi over 180. And hopefully you know where to put the pi so that they'll cancel. Okay? These aren't super tough. They're just a lot of simplifying of fractions. But fractions are a big deal in, this is another reason fractions are a big deal. It's one of the reasons I have the top 20 and need people to get their basic fractions, because you're going to be doing complicated fractions all the time now with pi's in them. Okay, moving on to this. This page is the only other page I want you to do for today. Since today was so packed with stuff, just 6 little questions. So on these, they want the sector length and the area of the sector. Sorry, this is the arc length. I wish they would call it A instead of S, but S stands for arc. So it doesn't tell me how big pi over 6 is, but does anybody have it memorized already? What's pi over 6? How many degrees? 30. Very good. If you didn't know that, you could multiply by 180 over pi, or pi over 180. In this case, 180 over pi. And the pi's will cancel, and it's 180 divided by 6, which is 30. So it's a 30-degree angle, and the radius was 12. I hope you know the SOAR formula, S equals theta r, and theta is pi over 6. Notice I can't use 30 in this formula. I have to use radians. And then the radius is 12. There's your length of the arc. And then the area of the sector, I like to do it with degrees. And you're going to get smart enough after a while to be like, oh, 360 is the same as how many degrees, or same as how many radians? 2 pi. So technically, you could do this with radians here. But I like to do it as 30 degrees out of 360, because I think people get that's 30 out of the total 360 degrees. And you times it by pi r squared. You do the rest of the math to get the area of that sector. If you wanted to, you could have used 2 pi here, because that's the same as 360, and you could have used pi over 6, But I think pi over 6 over 2 pi is an icky ratio, whereas 30 over 360 is kind of an easy one. So I like doing them in degrees. You can do them in radians if you want. And then the radius on this one's 12, so just stick in a 12 there and you'll have it. Okay. 6 questions for tonight. I don't think it's too rough. But you learned a lot of stuff, whether or not you're processing how much you've learned. That's a lot for one day.